Hello again, you sick, twisted weather freaks, and welcome to another fun filled, action packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist DT from weatherist.com here in Central Virginia, the captain of chaos, Colonel Confusion, and the commander of catastrophe. Let's talk about this week in weather, and this is a special edition dealing with the major winter storm coming here for the interior portions of the Middle Atlantic and southern New England, December 16th and 17th. This is what I call a MEX, a major East Coast snowstorm. So it's a MEX. So let's get right to it. First, here's a picture of my smiling face from Richmond, Virginia. There's my two emails. You want to reach me? There's the Twitter page, and there's the Facebook page. So before we get started, let me take a look briefly at Monday event. And the reason why I want to look at that is because there's something important about the Monday event in terms of teaching meteorology. So if you're a weather nut, a weather weenie, a weather hobbyist, this is kind of a useful thing I'm about to show you. So just bear with me for 1 second. Now, this is a pure rain event. Don't get me wrong, okay? There's going to be might be a little bit of snow in northern Pennsylvania and also West Virginia, the Greenbrier Valley, eastern West Virginia, western Maryland could get several inches of snow out of it. But this is the GFS. This is the Saturday run of the GFS. So here's our low pressure area. You can see it right here. There's the low, and we have our front, which goes up like this. Okay, there's a little bit of a weak high to the north, not a big deal. Now the temperatures right now are in the 50s and 60s, so a lot of warm air here. So this front comes southward. Now this is time frame here. This is early in the morning. This is 1 a.m. on Sunday morning, and here this is 7 a.m. So the low is here near Greensboro, and you can see the snow in West Virginia right there and the western Maryland. But this is all rain, pretty good rain too. It's going to rain pretty good, and then it goes like this. So the front is here. We're still trying to get a little colder coming southward. Now, the run appears to be colder than what the data was showing yesterday. So let's take a look-see here. So this is the GFS. This is again Saturday. This is today's midday GFS run on this Saturday afternoon, December 12th. Now look at the snow in New York City here. Okay, and just to the north and west of New York City, 3-4 inches of snow in here, 6 inches. 4 inches in Philadelphia, if that's correct, and then also at Lancaster towards Gettysburg, several inches, and then down in here you've got 6-7 inches of snow here as well. Now, is this correct or is this all bullshit? Now, most of this is bullshit, and I'll explain to you why. Because if you look at the actual soundings, and you'll see here in a second, this here is. I enlarge this a little bit so you can see it more. You can see it more certainty. Now, this is the 12Z GFS. And again, this is now this takes us through Monday evening. So this image here I just showed you, this is up till 1 o'clock on Monday when it's still precipitating in the northern Mid-Atlantic into New York City and Connecticut. And this is the total event. And look at the snow. Is that 8 inches of snow in New York City? Are you kidding me? Are you high? 6 inches in Philadelphia. 8 inches in I guess that would be Hagerstown. That's a little high. And then you get into the big snow in Greenbrier Valley. But let me show you what the problem is here. This is the sounding for, this is the GFS sounding, same model. It's valid for Monday evening at 7 p.m. And this is New York City. Look at the temperature, 37 and 32 degrees, dew point. That's not snow. That's not accumulating 6 or 8 inches of snow, folks. That's wrong. So even though the model is giving you this, and you go, oh my God, look at the snow in New York City. Ooh, the sounding, no, look at that. It's 37, 32 degrees. That's not snow. That sounding is too warm. That is a mixed precipitation event, and that is certainly not 8 inches of snow in New York City on this. Okay, maybe northwest New Jersey, maybe. And if you look at interior southeastern New York, and again, this is valid Monday, 1 o'clock in the afternoon. And if you look at the latitude to longitude, that's 41 north, so that's a little far to, that's northwest New Jersey, near the New York State border, near Suffern. And it's 33, 32. In northwest Jersey, you're cold enough for snow here. 33, 32. Not here. Look at the soundings in Philadelphia. It's the same thing. The soundings are too warm to support that sort of snow. Now, could it end as snow? Sure. Okay, and if there wasn't water on the ground, could there be an inch or two? Yes, but there's going to be water on the ground, and the temperatures are too warm. So all of this is just complete crap. Connecticut, yes. That could happen there. You could get a few inches there in Connecticut and even into Boston and southeastern Mass, because the air is coming in colder here sooner from the north, so that's possible. But New York City, Philadelphia, okay. If you're going to forecast, that's fine. You're going to get excited for Monday in that event. You're going to bust. This is what happened. This is what happened. That big storm up in Connecticut, New England, last way. That big nor'easter they had. Remember, Boston was everyone's talking 3 to 6, 4 to 8 for Boston. And what happened is the sounding. They even had more rain than they thought snow in Worcester because everyone ignored the sounding, which showed temperatures of 37. Dew point 32, which is just not a snow sounding for Boston or for southeastern Mass. So that's what happened, and a lot of people ignored that. They looked at the model data for Boston, they ignored the sounding data, and that was a problem. So, I'm not exactly sure how, with a sounding like this in New York City, you're going to get that much snow. I just don't see it. Okay. So, and sure enough, here is the NAM, which takes us into Monday evening, 7 p.m., when most of the event is over. It has an inch or two in New York City, not 6 or 8 inches. Look at Philadelphia, 0.6, not 6.1. See the difference? Look at Hagerstown, 1.5 as opposed to 8.1. Are you kidding me? Come on, folks, really? This is the European from last night, by the way, and you can see again it got like 2 inches in New York City. It has 2.5 at Hagerstown, very reasonable, and nice snow in all of Eastern Virginia. Eastern portions of West Virginia, you can see that into Western Maryland, 4, 5, 6, 7 inches of snow. Gettysburg, 4 or 5 inches. Lehigh Valley, 4 inches. Sure, Northwest New Jersey, absolutely. But there's a big difference between what's going on in Philly and these two maps. This is the NAM, this is the GFS, and look at the that's the European, that's the NAM. Look at the GFS. That's just bullshit. So I just want to point that out to you. Okay, let's get on to the big event. Okay, this here's our teleconnections map, and again, this is why I talk about this during the normal week in weather. These are our 4 different teleconnections. We have the negative EPO. We have positive PNA, negative Arctic oscillation, negative NAO. This is the ideal setup. So what all these are the different. When the setup is like this, notice all these things are in the right exact setup here. Okay. Now, of course, you can have a positive AO. You can have a positive EPO. It can be neutral. You can have a positive, negative, or neutral PNA. Same thing with a negative, positive, or neutral NAO. But ideally, for an East Coast snowstorm, what you want are these 4 teleconnections in those particular phases: a negative EPO, a positive PNA, a negative Arctic oscillation AO, and a negative NAO of the Greenland block. Plus, you want the 50-50 low. Now, you don't always get all 5 of these in the exact conditions, which is why the big East Coast snowstorm is rare. You don't always get them. So let's take a look at these teleconnections. Now, here is the Arctic oscillation, and you can clearly see that it is negative. There we are right now, and this is the event December 16th. So the Arctic oscillation here, the AO is clearly negative. Here's the NAO right there, and this is where you are right now, December 16, 17. There it is. It's clearly negative. Okay, that's good. We like that. All right, what's going on in the Pacific side? Look at the Pacific side, not as good. The PNA is neutral. You can clearly see right now it is. This is where it is right now, and during the event it's neutral, and the EPO also. There it is. It's negative right now, which is good, and then during the event it goes to neutral. So the Pacific side is not bad. It's just not ideal as the Atlantic side of things. So again, the NAO, the AO are excellent, but the PNA and the Pacific side, the EPO, not as good. Not terrible. So if we were to sum it up over the next 5 days, this is what we would see. We see the AO is negative, the NAO is negative, not strongly, but both negative. The EPO is positive to neutral, and the PNA is neutral. The MJO is in the neutral circle right now, so it's not a factor. And then again, over here we have our 50-50 low factor, which we'll get into in a second. And that is this feature right here, the 50-50 low. And here we have a multi-contour closed 500 low over southeastern Canada. And that's what that is. Now, my point about this is that by using these teleconnections and charting them, you can always see the big ones coming days ahead of time. This is always true, and it has been for the last 15, 20 years. This is how weather risk is able to make calls about snowstorms for East Coast much earlier than you'll see from the Weather Channel or your local TV people who are afraid to forecast beyond 3 days, or or what have you. This is, NWS. You'll see this. I do this all the time. So you can always see the big events coming days ahead of time. And just recall this: if you're a weather nut, if you're a snowstorm nut, remember the January blizzard in 2016 that had that huge snowfall in Richmond all the way up into Boston and New York. We saw that coming 7, 8 days ahead of time. Remember the January 1996 blizzard. How about the big snowstorm that hit central and southern Virginia 2 years ago? Just a couple of days ago on December 9, 10, 2018, in North Carolina, Virginia, Lynchburg, Richmond, Roanoke, Greensboro. We saw that coming 7 days ahead of time. Saw that coming. Remember the Christmas Day snowstorm a couple of years ago that hit from Norfolk up to New York City, right along the coast. Saw it coming 6, 7, 8 days ahead of time. The big ones you can always see coming days ahead of time. If you follow your teleconnections and you'll follow the pattern. And let me show you what I mean. This is the upper air. This is the surface maps from last night's European. Just gives you an idea. So I want to show you just what it looks like here. This is the high pressure system. This map is valid for Wednesday evening, December 16th. There's your big high, the Arctic high, pulling the cold air southward. There's the coastal low right here. The secondary low is dying. You got your ice right in the middle of Virginia. Then your heavy snow with Shenandoah Valley, West Virginia, Pennsylvania. And then it is moving up into Pennsylvania, New York City, New Jersey, Connecticut, Rhode Island, what have you, Southern Mass over here. So that's the classic coastal storm Miller B type of setup where one low dies, the other one jumps to the coast. Okay. Now, this is the upper air map. And again, textbook, you can see it coming. This here is your 50-50 low in southeastern Canada. We call it that because it is a 50 degrees north longitude, 50 degrees north latitude, 50 degrees west longitude in southeastern Canada, New Brunswick. Some people call it the NF low, which is the Newfoundland low because it's located by Newfoundland, Canada. But that's the feature. What this does is this pulls down the cold air, as you can see, and then the southern energy here has to stay south. See what it does? And that's why you say snowstorm. If this wasn't here, this energy would go up through Ohio, and you would have a Great Lakes Midwest snowstorm, and it'd be rain on the East Coast. That's why the 50-50 low is really, really freaking important. Okay. Now, what did the model show only a few days ago for December 16 to 17? Nothing. This was the European model from December 9th. Look at this. It had a trough, just an ordinary trough going like this. Maybe some sort of weak low here or here. Nothing. Not at all. Didn't, a weak 50-50. It was nothing. Nothing's going on here. And you can see. This was, if you look at the surface map, the European model from December 9th right here. Okay, we had one low. There's a low here right there. And then we had a secondary low here on the cold front. So there was no big transfer, no coastal bomb, nothing. It was showing rain. And we'll be like, okay, well, nothing's happening in mid-December. But I was telling you on the 3-week newsletter, on the Facebook page, and other places where I post that there was a real threat for mid-December snowstorm and winter storm here. And this is why. When you look at the European ensemble, it showed something. This is from December 9th. So this clearly showed a coastal storm here, a low developing, and another low here. So this one dies and jumps the energy to here, and this becomes the big storm. And the European model did detect it early on. The GFS was even more worthless than before. It had nothing, no indication of any sort of storm. Nothing, a Midwest storm. You can see there was some sort of piece of energy, shortwave here, okay, with that. But this is Ohio Valley storm right here, and then another piece of energy down this way. So it had nothing of any significance at all. And this was in fact, the GFS 500. If we enlarged it, this is for December 18th. It had nothing on the East Coast. It had a big storm over Oklahoma and Texas and Arkansas, Louisiana. I mean, this was the GFS. Again, this is for December 9th. This was on December 9th, valid for this for Thursday evening. Oops, let me bring it down here. And you can see we just have this, a big system. And let me change the you can see the surface map. There you go. There you go. December 18th. it just has a big rainstorm coming out of Louisiana and on the southeast coast. It completely missed it, and then there's a big rainstorm going up on the 19th and the 20th. So the GFS not only got the upper air pattern wrong, it had the date wrong, it had the event wrong. So complete miss on the GFS there. But that was only a few days ago. So you know, like I said, you can see the big events coming a long day off, and if you follow the teleconnections, you can see them coming way ahead of time, despite what the models are showing, despite when the models get crappy. So that's the one way of getting around this problem. All right. So now let's get into the event in more detail. There are several types of East Coast winter storms. So there's, and you may have heard of some of those terms. This is known as a Miller A, which is right here. This is the type A storm. And what happens is the main low develops in the southern jet stream down in the south. You have the big high over the Great Lakes pulling the cold air southward, and the low comes right up the coast just like this. You can see off the coast, and boom. All right. So that's the Miller A type of system. This is Miller B, where what happens is you have a secondary low which jumps to the coast here, and this results in also a significant winter storm. Now, usually what happens is the Miller A is snow for everybody from North Carolina all the way up to Boston. The Miller B is different because there's often a gap where there's no precipitation. When the first low dies and the second one jumps to the coast, there can be a hole in the coverage, which often includes portions of North Carolina and Virginia. So Miller B events usually are not good south of Washington, D.C. Usually they're not very good. Now, there are exceptions to this, obviously, but this is a general guideline. So the Miller A, and again, many of the storms in the past, the January 1996 blizzard was a Miller A. The February 2014 storm was a Miller A. The Millennial storm was a Miller B. The blizzard of 78 was a Miller B. The February 1969 snowstorm was Lindsay Dish, Miller B. There's lots of different examples of Miller B storms, but these are the two general types. There's also a third type, which is for Virginia and North Carolina, known as the Miller C. And this was the December 2018 snowstorm. And here what happens is the low stays to the south. The jet streams do not phase. You see the northern jet stream stays here and the southern jet stream stays here. But they don't phase. You don't get a big giant trough here. So what happens is the low ends up doing like this, and you don't get any snow north of Washington, D.C. in the Miller C type of system. Okay. The other feature is the 50-50 low. Now, what is the 50-50 low? Again, we get the term Newfoundland Low comes from the location of the system. The surface low is here, and the upper low is on the black lines there. It's located over Newfoundland, and like I said, it keeps the cold. The other thing it does is it keeps the Arctic high locked in place, so it can't slide off the coast. A lot of times, the high will come down. You'll be cold enough for snow in the Mid-Atlantic or New England, and then the high moves off the coast, and you get a south wind or a southeast wind, and your temperatures warm up. By having the 50-50 low here, it keeps the Arctic high in place, and you stay cold enough on the coast all the way through the event. So that's why that's important. This is what it also, another schematic of what it looks like. This is, you see the Greenland block? This here is your Greenland block right here. See that? And what it does is it forces the storm to stall over Newfoundland, and that sets up that forces the next system, the next low pressure area, to stay to the south. So, like I said, you can always see the big events coming. Always. And let's take a look at the schematic of how this is shaping up. Now, this is the GFS from last night, and this is from early Saturday morning. And the European, the bottom right, they're both showing the same thing. There's your 50-50 low. There and there. Here's your NAO, your Greenland block. There and there. There's your split jet stream. One branch of the jet stream is here, the other branch is here. See that? Split flow. See that? And then you have your southern low, which is neutrally tilted in a north to south orientation as it moves through Texas and Oklahoma. Perfect match. You can always see the big events coming. All right. And then finally what happens is this is the European here, just enlarged it. You can see the schematic with all the drawings on it. This is from last night as well. All right, let's take a look what happens. This is the European model. We're talking from the early Saturday morning, okay? This is all 0Z run for the time being. So this is from Pivotal Weather, and you can see that by 7 a.m. on Wednesday morning, the snow has gone over to sleet in the southern portions of the Virginia Piedmont and in northwest North Carolina. So Roanoke is right on the edge of snow going to sleet here, but the snow is already into DC by 7 a.m. Wednesday morning. The snow's in Tappahannock. There might be a mixture of snow and sleet in Richmond for an hour or two, maybe. It might just be all sleet and then go over to rain. But just to the north, Fredericksburg is all snow. Farmville is snow. Charlottesville, the entire Shenandoah Valley, from Roanoke all the way up to Winchester, Martinsburg, Leesburg, all snow, heavy snow going on here at the time. And you can see the cold air damming very pronounced. Look at the isobars. You see how you get these kinks in the isobars? Okay, you see how it does that? That's all the signature of cold air damming. The cold air is being forced down this direction. And there's the low forming on the coast. There's the primary low here. Here's the secondary low. This one's going to die, and this one's going to become the big one. And now, this is the Canadian model, which last night went bonkers. I mean, absolutely off its stump. And you can see what it was doing. It had a huge area of extremely heavy snow, 18 to 30 inches here. That's western and central Connecticut, New York City, southeast interior New York, northern New Jersey, just to the north, well, into Philadelphia and the Lehigh Valley, down into Lancaster and Gettysburg, and into Baltimore and Hagerstown and Havre de Grace and Leesburg and Gainesville and Ashburn, just all the way down to Front Royal. I mean, it was a monster snowstorm. The problem here is that the data actually doesn't support that. Now, this is again, this is where the GFS was showing the change over here for what it looked like on Wednesday morning at 7 a.m. If we break it down every 3 hours on the European, we can see what was going on here. This is the last night's. This is early Saturday morning. This is AM, okay, Saturday models. That's what we're looking at here. Okay, so the purple line on these maps here is the 32-degree isotherm. See that? 32 degrees. And then the zero line is the 850 isotherm. So to get snow, okay, you have to be north of the blue line. You have to be north of the blue line. So look at Roanoke right now. Roanoke, okay, at 10 a.m. on Wednesday morning is snowing. So is Lynchburg. Right? But south of Roanoke, in, let's say, Whiteville or these other places in southwest Virginia, Greensboro, this is all ice down here. See that? This is all ice in here. Now that snow's developing. Now, we get to 1 o'clock Wednesday morning, the snow has reached D.C. 1 o'clock Wednesday afternoon, I should say, sorry. The snow has reached D.C. Now, look at the blue line is at Roanoke and north of Lynchburg and north of Richmond. So this is ice in here, folks. Lynchburg down to Greensboro. Roanoke, this is all ice. Whiteville, all ice. Hillsville, all Danville, same thing. And north of that, in the central and northern Shenandoah Valley, east and west Virginia, it's snowing pretty good. And we have heavy rain in the southeastern states. Okay, so far so good. And this is what it looks like at 1 o'clock. If you want a nice, pretty schematic with lots of colors in it, you can see the frozen rain here. Here's Richmond. As you can see, Richmond is all rain right here. There's D.C., there's Baltimore, there's Charlottesville. This is Roanoke. Got your bearings? Okay, there's Winchester. See that? Okay. So you can see where the heavy snow is. It's coming down like a bucket in the Shenandoah Valley. And it's coming down hard. And the Virginia Piedmont is getting slammed with an ice storm. That whether that's freezing rain or sleet, I don't know yet. We don't know yet to that degree. It's too far out. All right. This is now Wednesday at 5 o'clock. Look at the ice storm going on in the southern Virginia Piedmont from Charlottesville just north of Roanoke, maybe by Bluefield, everything south of that, Lynchburg ice, Roanoke ice, Dansville ice, Martinsville ice, Whiteville ice. Now, north of the blue line, look at the northern half of the Shenandoah Valley in eastern West Virginia. They're getting pounded with the snow, really coming down there. And then by 7 o'clock Wednesday evening, this is 7 p.m. down here. Okay, this is 7 p.m. Wednesday, right here, okay? Heavy snow is now into Philadelphia, just about to reach Philadelphia. It's definitely snowing like a banshee in Washington, D.C. But notice the zero line is very, very close to Washington at 7 o'clock. Okay, so they may be mixing. And the 32-degree line is to the south and east of Washington and Baltimore. So South and east of there, they're getting ice. So Manassas is probably freezing rain or sleet at this point. Fredericksburg as well. The snow line is right on Charlottesville. Notice that the zero line has moved back now south of Roanoke. So they've gone back over. So let's take, I'm going to enlarge this a little bit. You can see what's going on here a little bit. You see how the blue line, which is the snow line here, the approximate snow line, is now moved south of Roanoke. But look where it's up by North Baltimore and DC. It's north of it. So this is mixed precipitation here, or ice, and all the way down at here. And of course Richmond is 34, 35 degrees and raining. Yay for Richmond. But the Virginia Piedmont getting pounded with an ice storm. And this is Charlottesville's all snow. The entire Shenandoah Valley, all snow up into central Maryland here. So that's a nice, interesting map. Okay. This is what it looks like with the pretty colors. 7 o'clock Wednesday evening. It's coming down in the valley. This is a classic I-81 snowstorm from Blacksburg and Roanoke all the way up the valley into Winchester, Martinsburg, Hagerstown. Classic I-81 snowstorm. Virginia Piedmont, big ice. Notice that according to this schematic, DC is plain rain. No, I don't think that's, I think it's a little too warm, but if it's not plain rain, it's freezing rain. So, okay. Now, I was talking to other people the other day. They were arguing, no, DC is going to stay. No, it's not. It's going to go over. But they're going to get a lot of snow ahead of time, and they're going to go back to snow. So it's a mixed bag in DC. And just to the north and west, it's going to be awesome. Okay. Now, this here is, again, the early morning Saturday European model. This is now 10 o'clock Wednesday evening. There's the low in northeast of Hatteras. And you can see that the snow line, let me enlarge this so you can see it a little bit, is still, oops, I'll bring this forward. You can see the snow line, the blue line is still north of DC and Baltimore, and it's over Philadelphia. So they got mixed precipitation here, but DC is very close to 32 degrees. So there you go. Charlottesville, still snowing. Now, just to the east of Charlottesville, like Lake Monticello or Gordonsville or what have you, it's, you know, or let's say Union Mills and places like that. Zion, it's probably ice. Okay, but notice Roanoke is still snowing. Lynchburg has gone back to snow. The entire Shenandoah Valley and the northern half of Shenandoah Valley is just getting pounded. Look at this heavy snow. This is this is an inch liquid in a 6-hour time frame. That's that's a lot of precipitation in just 6 hours. That's a lot of snow. Okay, and then finally, this image here. Let me bring this front, and you can see. This is now 1 o'clock on Wednesday morning. It's snowing like hell in DC again, in Baltimore. No doubt about it. Snowing like hell there. There's the blue line. And again, it's still snowing in Charlottesville. Looks like it shut off in Roanoke, Lynchburg finally. But the northern half of the valley is still getting hammered. Big, and this monster snowstorm into Pennsylvania, Allentown, just north of Philly, Lancaster, Gettysburg, maybe as far west as Altoona. Go heading out towards Allentown, Wilkesboro, Scranton. Monster snow developing now in New York City, just to the north. Notice southern New Jersey's rain. Delaware here's rain. The low is too close to the coast. You see how close the low is? That's just rain all in here. That's the problem here. And then if we finally, let me see. And then this is, if you want to look at, again, the schematic, nice and pretty. There it is. You can see the low. It's very close to the coast here. Right there. See that? That's just not good enough for southern New Jersey. Now, it's gone back over to snow in the northern Delmarva. You can see that right here. It's all snow. This is 7 a.m. Thursday morning. It looks like it's about to stop in D.C. But northern Hagerstown, Frederick's still getting snow. Gettysburg, look at all this monster snow here in New York City, Pennsylvania, New Jersey, northern New Jersey, southern New York. Big, big snow coming. This is going to be a big freaking deal. And this is where it is, if you want to look at it. By New England, it's still getting pounded. This is, again, this is just to show you Thursday morning, 1 a.m., and then it's moving off rapidly at this point here. Notice it really does not get much further north than the Connecticut, than the Massachusetts, Vermont, New Hampshire border. There's nothing really north of this on these models, north of this line. Most of the heavy snow stays, that far south. It doesn't really get into southern Vermont and New Hampshire. It doesn't really get north of Kingston, New York, for that matter. North of, not much further north than, I don't know, Newburgh or Poughkeepsie. Now, if we wanted to look at the European map from early Saturday morning, this was the snow. Notice the heaviest snow, 5.3 inches in Charlottesville, 3.7 in D.C., 9.8 in Baltimore, Roanoke 5.6. But the super heavy snow is just to the northwest of all of these areas. Now Philadelphia is 12 inches, and there you go. In DC, New York City, maybe 16 inches of snow there on this, and you can see. Look at the 2 feet of snow here in portions of Pennsylvania. Look at that. Holy cow! Now Shenandoah Valley, northern Shenandoah Valley, Winchester, 21 inches of snow. Hagerstown, 18 inches of snow. So this is the big deal, and that's the European from last night. The other thing the European was showing is the ice in the Piedmont. Look at that. 0.52 inches, 0.65 in Lynchburg. That's a lot of ice. That's going to bring down some power lines, boys and girls. That is not good. If you're in the Virginia Piedmont, this looks like a ice storm. All right. This here was this is the GFS map from last night as well. You can see it. Let me shrink this down a little bit, and you can see it's got the same sort of thing. Now it has 2 inches of snow in Richmond. That's bullshit. That's not going to happen. And because it is a colder model, it has more snow in Washington, D.C. when compared to the European. The European has 3.7. Last night's GFS had 10 inches. I mean, it's just same thing. Charlottesville, 10 inches versus 5.3. And you can see the difference right here. Here's the GFS. You can see on Wednesday morning, Wednesday 1 o'clock in the afternoon, the snow line is still south of Charlottesville, just north of Roanoke, and then it comes southward in the evening. When the cold day comes pushing backwards, that is of course further south than the European. So that's what and then you can see the Canadian is even colder. The Canadian, you can see, has the rain snow line 7 o'clock Wednesday evening, almost in Richmond, which is bullshit. The low is right here. It's way too cold. Monster snow in this area, which is fine, but it's got it too far east. And that's a result. The model does this, shows this monster snowstorm. It's okay. This is the Canadian, regular Canadian. Notice it's got 9 inches in Charlottesville. That's possible. 8 inches in Roanoke. Okay. It's got 18 in D.C. and 20 in Baltimore, and then big snows. This is all very, very possible in this kind of snowstorm. The problem is here is when the Canadian lost its mind. This is the Canadian Cushera model here, and you can see it has 18 to 30 inches. I mean, just completely lost its mind last night. This particular version, this is a special run of the Canadian. This is the regular Canadian. This is the Canadian Cushera model. You can see, 30 inches of snow is just a little much. And when you compare it to the Canadian Ensemble, you'll see that it doesn't support this at all. This is very different from this. Notice there's no snow here over 12 inches on the Canadian Ensemble. So the operational run is going bonkers, but the Ensemble has a big snowstorm but doesn't have anything over 12 inches. And the other problem with ensembles are this. Now this is the snowfall from the European model last night for Roanoke. I just want to show you. The mean here is 4 inches. You can see the blue line. Okay, the mean is about 4.4 inches for the storm once the storm hits. But if you take a look at the total snowfall for the event, if you look at any one particular front, look at the orange here. You can see different snow varies, all the different models here. And if you look at just like say right here when the snowstorm coming for next week, look at the variations here: 0.2, 6, 5, 4, 9, 3. You're not getting any. It's just too big of a range. So your mean here is actually hurting you because now you're saying, well, it could be 1 inch, it could be 9 inches. Well, that's not a forecast. That doesn't help you. So sometimes the ensembles can hurt you. I just want to show you also the European. This is the 6Z run from this morning, and you can see early this morning, the same sort of thing. No change at all here. You can see here for 10 o'clock. This was low. This was Wednesday at 4 o'clock in the afternoon, and you can see the 32-degree line is here, and the rain snow line is there. So again, we got a lot of ice in the southern Virginia Piedmont, and then in the evening, you can see that the zero line is now here. So it's gone back to all snow in Roanoke and southwest Virginia. Still all snowing like hell in Shenandoah Valley. It's gone back to snow in D.C., in Baltimore, and Philadelphia. And that was the 6Z one. So let's look at the 12Z data. Here you go. This is the European model from, again, this afternoon. You can see the ice very clearly pronounced. This is the snow line here. This is 32 degrees here. So this is your snow line. So this is all ice Wednesday morning, 7 a.m. And then by 11 o'clock in the morning, it's breaking out towards Charlottesville. This is all ice in here, and this is snow here, and snow here, and snow in Ohio and northern Kentucky. So that's okay. That's not a change. And then this is 1 o'clock Wednesday, and then 4 o'clock on Wednesday. And you can see the big ice storm now. The European model has the snow line north of Roanoke or Lynchburg, up by Charlottesville. See that? So this is all heavy, heavy ice in here. And then by 4 o'clock on Wednesday, the rain snow line is moved just to the north of Charlottesville and almost south of DC, just south of DC, and that's Manassas. You see that? So again, this is freezing rain or sleet in here at this point. And that's a little warmer than what we saw earlier. And then this is now this is the GFS from this afternoon. Now I want to show you the difference here. This is the 18Z GFS, and let me see where the 18Z. Yeah, you can see the clear difference here on the 18Z. Look. Let me make sure I got the right map up here. Yeah. So this is the GFS, and you can see that 102 hours, which is 1 o'clock on Wednesday, the rain snow line is still way to the south. You see the line here? Way to the south of Roanoke and by Richmond. So this is saying at 1 o'clock in Richmond, it's snowing here. Well, no, that's bullshit. That's not going to happen. But the rain snow line is still south of Roanoke and Lynchburg. So this is all still snow here. So as a result, the GFS has more snow in the southern half of the Shenandoah Valley and the Virginia Piedmont than the European does. This is the European 108 hours, you can see, Wednesday evening. Now, if we enlarge this a little bit, bring it forward, you can see by 7 o'clock on Wednesday evening on the new European model, there's your rain snow line here. Roanoke to Charlottesville, north of DC, up towards Philly. And this is ice or sleet in here, all of this. DC, Philadelphia, sleet, Charlottesville, snow and sleet, Fredericksburg, sleet, Lynchburg, Roanoke, sleeting. But it's beginning to turn back. So as the low moves away, the cold air comes back in and it turns colder. So let's shrink this one. And this one here we can enlarge a little bit, and you can see that now the snow line has moved back towards south of Roanoke again. See that? Oops. And you can see the line here. Now it's moved south of DC. The DC, Baltimore, all snow here. As the low moves away, it pulls the colder area in. So whatever mixing now has gone back to snow in the central Virginia Piedmont. So so it's going to go back over to snow, no doubt about there. This is the GFS for 7 o'clock in the evening, and you can see that the snow line stays south of DC and Baltimore. So again, it's significantly different than what here's the European. See, the snow line is north of DC and Baltimore. See the blue line? And there's the GFS, south of it. See the difference? There you go. So that's a big difference in the snow mounts. Huge. Here's the European for 10 o'clock on Wednesday evening in the upper left. And the blue line, again, doesn't go south of Philly, south of DC, Baltimore, south of Charlottesville, south of Roanoke. Now the 32-degree line, the sleet line have maxed out. They've met. And you can see the huge amounts of precipitation coming down. Look at that on Wednesday evening, late Wednesday evening, 10 o'clock in northern Virginia. I mean, this is like 2 feet of snow potentially here in this area, all this area. Very, very heavy snow coming down from Charlottesville to Hagerstown. And then if we shrink this, there it is. Now that big blue area has moved into Philly in eastern Pennsylvania. By 7, now this is early Thursday morning. The snow is still going on in DC, Baltimore. Still snowing there very heavily. It's ended at Charlottesville. It's about to end in northern Virginia. And then finally it pushes on off. You can see there's to New Jersey by 7 o'clock Thursday morning. It's ended in DC, about to end in Baltimore. But it's snowing like hell in eastern Pennsylvania, New Jersey, New York City, Connecticut. And this is what it looks like in New England. You can see again, notice the heavy snow does not get north of the northern Massachusetts state line at all. And then if you want to look at the snow amounts, this is the GFS. Now, why does it have this much snow? Because again, it's got the snow line, if you remember, stays much further south. So New Roanoke gets 8, almost 9 inches of snow, Charlottesville 10 inches. The European has that line up here. So this is not, this whole area get a lot less snow in the European. And you'll see that in just a second. This is the Canadian, which is also showing a lot of ice in the southern Virginia Piedmont and Roanoke. Now here is the Canadian. Again, the Kushera model, like last night, showing areas almost 30 inches of snow here, 20 to 30 inches of snow from just in Northern Virginia, just to the north and west of Washington and Baltimore, Hagerstown, Frederick, Gettysburg, Lancaster, Harrisburg, Philadelphia, Allentown, New Jersey, just to the north of New York City, Poughkeepsie, Western Connecticut. But if you look at the regular Canadian without the enhanced snow algorithm, you'll see you don't get that at all. So, oops, let me change that. Um, so you don't get that at all. See a big difference. So it's still a decent snowstorm. Charlottesville still getting 9 inches of snow. Roanoke 5 inches, a lot of sleet. DC 15 inches of snow, nothing to that's a really good snowstorm. So it's just not 30 inches, but it's there you go. Philadelphia 11 inches, New York City 16 inches, Central Jersey 20, Allentown 17. Canadians a very nice snowstorm. No reason and the regular Canadian. So and then here is the GFS this afternoon, the 12Z run. And again, notice, large is even more. You can see it's got more snow in the Virginia Piedmont than the European does. And look at the snow amounts again in and around New York City and eastern Pennsylvania. Look at that. Wow. It has a lot more snow in southern New Jersey, which is not correct. As you saw from the Europeans, way too warm in southern New Jersey for this kind of snow. It's just way too warm for that. Okay. And then I believe this next one here is the European. It is. Look, so we can compare the difference. It's like Charlottesville, 6.9, 13. That's a big difference. GFS, 10 inches in Roanoke. European, 4.9. Big difference. Big difference. So, but in Northern Valley, Central Maryland, European has 12 inches in DC, 15 in Baltimore, 17 in Philly, 18 in New York City. Very nice snowstorm. Really very impressive. And again, 20 inches possible interior South Central Pennsylvania. One other thing here to end it is look at the winds. These are knots, okay? So, if you're looking 30 knots, it's 35 miles an hour in Pennsylvania. 45 knots, that's 50 miles an hour. 30 knots in DC and Baltimore. Okay, this is with that amount of snow, you could be looking at the B word here, folks. No doubt about it. So don't be surprised if they issue blizzard warnings or watches during this storm on Tuesday from the National Weather Service. Okay, this has been a very long video. Sorry about that. A lot to say, but I wanted to do a really good analysis. Hopefully you enjoyed this. This is meteorologist DT from Weather Risk. I'll talk to you soon.